Okay, I'm here for uh, August 19th. Starting off with physiology. This one's a big one. Okay, so epithelium. There's glandular epithelium and there's um, well, hold on. So epithelia can be glandular or polarized. If something's glandular, that means it secretes something. And if something has polarization, that means the cells like kind of know what's going on around them. They have sightedness. Um, Morphology is how a cell looks and appears. There's going to be a lot of H&E stains in this class, but again, I can't show pictures for legal reasons, unfortunately. But this is more for me, kind of, for studying, but hopefully some people will find this helpful. On H&E stains, the pink parts are protein and the purple parts could be protein, but it's too strong to say for sure, really. There's 4 types of tissue. There's nervous tissue, muscle tissue, connective tissue, and epithelial tissue. In epithelial tissue, the cells are very close. They're usually lining some surface in the body, like the skin, the mouth. They've got points of attachment. The lumen of the intestine, that's an example. The brain ventricle. And if there's no epithelium, but there's a space, then it's probably an issue. It's likely a pathology. Thank you, Brooklyn. I agree. Okay. Okay, general features of epithelium is that they have one surface that's free. So like for your skin, you've got this surface, it's the free surface. It's exposed to everything. Yep, hi. And the cells are tightly packed together, though. There's little to no material inside the cell, so basically no intercellular material. And cells that are joined by intercellular junctions, there's connective tissue under them that supports those. And they're separate from that connective tissue, however, by the basement membrane, the basal layer of the epithelium. And these are avascular. Epithelial cells are avascular. That means they have no blood supply. I mean, they have blood supply, but no like blood vessels in the epithelial sheet. I don't know if they have blood supply, to be honest. Again, I'm just reviewing my notes that I wrote down. I should probably look that up. Okay, so in the endocrine system, glands are present. The functions of the epithelium, they regulate molecular transport by separating luminal space, that's the space like inside whatever the epithelium's encapsulating. And they separate that from the basal portion of the cell because some of these luminal spaces are secreting important molecules. Okay, we have 6 types of epithelium here. There's simple squamous, simple cuboidal, simple columnar, like columns, non-keratinizing stratified squamous, transitional epithelium, and ciliated pseudostratified columnar epithelium. Yeah. So something is simple when it's only got one cell layer. If it's got more than one cell layer, it's stratified. All of the epithelial cells rest on a basement membrane, but not all. Oh, okay, sorry. When all the cells rest on a basement membrane, but not all of the cells reach a free surface, that's pseudostratified. So I guess it's not really stratified. Okay, yeah, because all the cells are on the bottom, but there's only like one layer technically. But they don't translate either all the way to the top, or they don't translate from the top all the way to the bottom. Wait, no, all the cells touch the basement membrane. Never mind. So not all of them go to the top, basically. It's hard to know 100% which ones are those, though. Respiratory epithelial cells, cells in the epididymis, cells in the nose. These are pseudostratified. When the nucleus bulges out, usually that's a squamous cell. And those are also thin and flat. But if the height equals the width, then they're cuboidal, like a cube. And then we have, okay, so the thin and flat ones, that's basically where the height is less than the width. Those are the squamous ones. So it's easy to differentiate. The ones that are kind of flat, those are squamous. The ones that are same width and height, those are cuboidal. And then the ones that are taller than they are wide are columnar, because they're columns. Yeah, it was pretty much just the same thing. Hmm. So you can combine the names, like stratified squamous, that's skin. Stratified cuboidal is lining of excretory ducts, of exocrine glands. Mhm. Yeah, most simple squamous is found on the surface of organs. On serosal surfaces, it's called mesothelium. But there's these things called potential spaces. Um, these are the peritoneal cavity, the pericardial, and the pleural cavity. There's not normally a space there, but a space can be created. Like if an animal were shot, then a space might open up in those spaces. The pericardial space, that's the space between the pericardium and the heart, right? The pericardium is the membrane surrounding the heart. The peritoneal space, that is it's the peritoneum, right? That's the gut lining, kind of. I think, if I remember right. These potential spaces, they happen because of a development. It's not, or like during development. Um, I think they kind of go away as you get older, though, or as an animal gets older. They're also called serosal spaces, but that's not used often. And this is important clinically because bad things can happen that you need to be aware of involving these spaces. Okay, I've got a picture of mesothelium here. You guys aren't going to be able to see it, but there's parts that are pale, kind of. The stain was not absorbed as much. And what that means is that there's low protein. Because this is an H&E stain, again, I can't show it to you because it's illegal. But this H&E stain of this mesothelium, what H&E, I can't really remember what it means. I know the E is eosin, I think. And anyway, the tissue that has more protein is going to be pink, whereas the tissue that doesn't have as much protein is going to be white. So, okay, there's serous membranes. Those line the serosal cavities. These are closed cavities of the body. The pleural, peritoneal, and pericardial. I probably need to remember that. Okay, and then mesothelium is not glandular, so it doesn't secrete anything. However, it is covered by a watery fluid, like many epithelia are. Serous membranes. Some examples of serous membranes are mesothelium and the connective tissue under it. Okay, simple columnar epithelium. It's literally just columns. Like, it's just cells side by side and they're in columns. Wow. Okay, and then Okay, something can be keratinized or not. So things that need more protection are going to be keratinized. Like in certain animals, the oral cavity might be keratinized. Like in sheep, for example, they've got a keratin. I think it's a keratin-based pad on the top of their mouth called I don't know what it's called. I'll be dead honest. It's they're munching that grass and they're kind of grinding it up against the roof of their mouth. That's in a lot of herbivores actually. Cows, the same. Yeah. And I don't know why this isn't moving. Strange. Oh well. And keratinized cells have no nuclei. It's basically dead stuff. So epidermis is basically just dead skin. But it's exposed to the air, so I mean, why would we want it to be alive, if we're trying to make a barrier to whatever the skin is in contact with? You're trying to protect the skin. You're trying to protect those cells, and so it literally makes a barrier to the outside world. It's the first line of defense. And there's more in some areas of the body. Like some areas of the body have a lot of keratinization, some have none. Like a dog's paw pads, for example, very keratinized, whereas their I don't know. I don't know any examples of non-keratinized. Probably like I don't know. Something in the eye, maybe. I don't know. Okay, transitional epithelium. It's only found in the urinary tract. This is an intermediate between stratified squamous cells and columnar. It's got both, basically. It's got some squamous and then some columnar on top of it, columns. And it changes the shape of the layers when the lumen gets more distinct. And when it's distended, that layer becomes more flat, but the intercellular connections stay the same. Now, for ciliated pseudostratified columnar epithelium. This is the only this is the only epithelium that has cilia, which are like the tiny, almost like tiny little hairs. This can be found in the trachea, the bronchial tree, and different ductules of the epididymis. And some people use the term respiratory epithelium for ciliated pseudostratified columnar epithelium. Now, back to glandular epithelium. Some epithelial cells are specialized specifically for secreting things, like thyroid cells. They secrete thyroxine, which is thyroid hormone. Stomach cells, they secrete mucus, right, to protect the lining of the stomach from the hydrochloric acid. And then pancreas cells, they secrete insulin and other enzymes to degrade material, just to degrade stuff that's in the small intestine. Now, exocrine versus endocrine. Endocrine diffuses its secretion into surrounding connective tissue. Hold on, I'm thinking. So, epithelium, muscle. What was it? Nervous, muscle, epithelial, and hold on. 17. Nervous, muscle, connective, and epithelial. Those are the 4 types of tissue. So endocrine diffuses whatever it's secreting into surrounding connective tissue, I think. So this is blood vessels, so it takes that secretion and carries it by the blood to the site of action. And those secreted molecules are called hormones. Endocrine system. Now the exocrine system secretes molecules either directly onto a free epithelial surface or through a duct to the site of action, like a tube, I guess, kind of. Now in the body, it's obviously very small. It's not a tube. It's like a vessel. But yeah, endocrine's usually secreting it into the blood to go around to the body, whereas exocrine is secreting it directly to a surface, I think. Okay, and that was it for physiology and histology for the 19th. And then I had some more here. The cell is the smallest unit of life, bounded by a plasma membrane. It's got nucleus, cytoplasm, etc. It's got a membrane, which is the phospholipid bilayer, and that phospholipid bilayer is composed of cholesterol, glycolipids, and sphingomyelin. I've never heard that one before. Also, membrane proteins, ion channels, ion pumps, hormone receptors. Some proteins don't cross this phospholipid bilayer, but some do, and then some are part of it. Like you've got, what are those proteins? Okay, I literally just had it in my mind. So there's certain proteins that act as a channel for specific things that can't like get into the cell by themselves. They need help, facilitated transport or facilitated diffusion, whatever. I think that's, if I recall correctly. These membranes have a trilaminar structure. They've got the lamina densa, the lamina lucida, and the lamina fibroreticularis. Yeah, fibroreticularis. I'll talk a little bit more about those later. There are sugar chains on the plasma membrane. These are attached to glycoproteins or glycolipids on that membrane, and they're termed glycocalyx. Glycocalyx? I don't know how you say that. It's spelled Glycocalyx. Never heard of that before. Okay, and then ribosomes make proteins, lysosomes break down stuff. This was just review, so I just kind of etched down some stuff. Endoplasmic reticulum, mitochondrion, glycogen and lipid droplets, and cytoskeletal elements. Yeah, it's pretty much just review of basic biology. And yeah, that was physiology. Now onto nutrition. Okay. All right. So nutrition is very important. And it's one of my favorite fields, actually. But nutrition is the single major determinant of animal health, welfare, or production. The single major determinant, most important thing. Now, veterinary nutrition is the clinical science of providing appropriate diets to animals to optimize their health and well-being. It's species specific, right? Not every animal eats the same things. It's important to educate pet owners, and then you got to evaluate the differences between commercial, home-cooked, or therapeutic diets, because there might be reasons why people would use either or. Now, nutrition, correct nutrition or lack thereof, affects disease prevention. I mean, you see this in obesity, dental disease. It affects treatments, how well you heal or how well your animal heals. And because, I mean, some foods can cause allergies or gut issues. And then it also affects the overall quality of life for that animal and how long they live. And it's been measured and modified in clinical practice. The job of the veterinarian is to be a source of information for clients who want to know about nutrition for their animal. And then our job is to evaluate diets, understand and interpret pet food labels, and then to identify nutritional deficiencies, toxicities, and imbalances. And there's also a lot of misinformation, so our job's to address that as well. The field of nutrition is a very controversial one. Used to be not taught much to veterinarians, frankly. Um, Doctors would just prescribe pills and say, go on your way. But now it's becoming more evidence-based. There's good evidence that elimination diets are very helpful, etc. And so it's a good idea to do research. Lots of pet owners don't go to their vet to look for nutrition advice because of misinformation, distrust of the big pet food industries, preference for raw or home cooked diets. Some people just want to do that, which is okay. And then ethical concerns, which is, these are all valid concerns. And our job as veterinarians is to change the bad view that clients have of veterinary nutrition by communicating it clearly, reframing science and ideas in terms that are familiar to clients, like not supposed to, you don't want to be talking like Albert Einstein when you're talking to a client, or else they might not understand. And then education, of course. And then this is probably first and foremost, including the owner in their decision because it's their pet. It's not our pet. So, okay, moving on. Nutrients, fats, carbs, water, protein, minerals, vitamins. Yep. There's non-essential and essential nutrients. Non-essential nutrients are still included though because they are good for physiological functions. They can promote health, good health, and they can also make the food taste better. And whenever the animal gets older, or whenever the animals get older, they just have trouble, whether it be illness, stress, or just getting old. They can use those non-essential nutrients to it just helps their protein synthesis and other stuff probably. But that's why they're still included in diets. And just because something's not essential doesn't mean you don't need it. It just means that you can't make it. Essential. If something is essential, it means you can't make it. But if something's essential, you cannot make it. And if it's non-essential, usually that means you can make it. Sometimes it just means that you can't make enough. So that's how that works. Anyway, nutrient availability, bioavailability, and digestibility. Those are pretty important when you're talking about nutrition. Because not all foods are completely bioavailable and not all foods are completely digestible, especially for humans. Think about it. You eat a bunch of, I don't know, you go to Golden Corral or something and you pig out, you just eat everything in sight. You're probably going to have a big old turd when you get home. Or I don't know. You know what I mean? But whereas if you eat meat and egg, and that's all you eat, and I've tested this, so I know it's true, because there's no fiber, which is just bulk and undigestible, at least for humans, and that's pretty much the only thing, honestly. Your fecal bulk will be greatly decreased. So, but if you eat like meat and eggs, you probably won't poop for maybe a day, or you probably just poop once a day. That's, that's pretty common. Sometimes it's every other day. Just depends on the person. Anyway, there's also regulations for animal feed. The FDA is the primary regulator. They make sure the feed is safe. They make sure it's made properly, labeled properly. And then they also oversee the Center for Veterinary Medicine, which they oversee and approve food additives and drugs for animals. And they also monitor feed contaminants and they make sure everything's up to standard, basically. Now, AAFCO, the Association of American Feed Control Officials, AAFCO, they're basically they make the models and the standards. They develop the laws and the regulations. They define pet food ingredient terms and nutrient profiles. They also establish protocols for feeding trials. If you ever see complete and balanced or balanced on a feed, then that's something that AAFCO put there. And that's a certification that means, like, if you feed this to a dog, they're going to get everything they need. And if they've got clinical trials to back it up. Okay, and then USDA, the U.S. Department of Agriculture, they basically regulate specific ingredients like meat, chicken, and egg. They also decide if something's organic or not. They label it that way. They generally ensure that these ingredients are safe and properly labeled. Now, the FTC, the Federal Trade Commission, that's the full name, they are responsible for protecting advertising and marketing claims. Like if someone says this food contains I don't know. Like if someone says that a food I don't know. FTC. Okay, like if they say it's 90% protein, which is pretty crazy. But if they say that, then they test it to make sure it is. And if it's not, then it's false advertising. Okay, then there's state regulators or agricultural departments in each state. They adopt those AAFCO model laws. They also give licenses and registrations for feed manufacturers and distributors. And then they inspect, sample, and test those feeds. They enforce label, safety, and nutritional standards. And they also, again, like I said, they collaborate with the FDA, USDA, and AAFCO, AAFCO. Okay, moving on to the digestive tract. So, the functions of the GI tract are to protect from microbes and toxins, because the gut is technically open to the environment. It's a through hole. Think about it. Mouth, food goes in the mouth, comes out the butthole. Just to be crude. In through the mouth, comes out the anus. So it's a through hole. That means you've literally got a hole going through you. Now there's There's valves, there's things in play, and I'm about to talk about a few of those. The epithelial cells are the only barrier between the environment and the bloodstream in your body, in your GI tract. There's a couple other defenses as well. There's secretions like stomach acid that are not conducive to bacterial growth. Peristalsis, that's the contractual rhythmic moving of your gut that like moves stuff down. It's like an accordion, you know, or I don't know. It's it just kind of squeezes that stuff out of you. And then there's commensal bacteria, the microbiome, you know. Very helpful if you've got a good one, that is. Because you can really mess up your microbiome, and then that can really mess up your health. Okay, so the gut is the largest immune organ of the body. The largest organ of the body is the skin, I think. It's also the most visible organ of the body, obviously. There's plenty of, oh man, lymphoid tissues. I'll talk about that later. Gut-associated lymphoid tissue. Then there's these things called Peyer's patches. I don't know, Peyer. What they do is they basically sample or process antigens, and they do that so that they can increase the body's tolerance or defense to those antigens. They also, the Peyer patches generate B cells and secretory IgA. I don't know what that is. Oh, okay. It says IgA is considered the first line of defense, which binds to and promotes the clearance of antigens, blocks any access to the epithelial receptors, and facilitates their removal. Okay. Two very big differences between monogastric GI tracts and ruminant GI tracts. Monogastrics only have one compartment of the stomach. Well, they have a stomach, period. Ruminants don't have a stomach. They have a true stomach, but it's not called a stomach. It's called an abomasum. Monogastrics have limited capacity, limited microbial fermentation in their GI tract, and then they also need nutrient-dense foods. Because, and what that means, what nutrient-dense means is like the food has nutrients that are easily accessible, concentrated, well-balanced. Now, well-balanced, that's kind of a vague term because that can mean multiple things, but I'm not going to get into that. Yeah, they basically, I mean, if you're think about a cat or a lion, what does a lion eat? Meat, right? What does meat have in it? Plenty of vitamins, plenty of minerals, plenty of protein, plenty of fat, you know? Whereas, what's a ruminant eating? Grass, or like a cow, you know? Cows eat grass. What does grass have in it? Yeah, it's got all those, it's got vitamins and stuff, but the access is locked because they're in the cellulose. And that's why a ruminant has multiple compartments of its digestive tract. The rumen, reticulum, omasum, abomasum. And they've got very high storage capacity in that GI tract. Lots of microbial fermentation. Matter of fact, they rely on microbial fermentation. Without it, they'd not be ruminants. And these microbes give them a lot of benefits because they literally digest the microbes to some extent. These microbes provide energy, protein, and B vitamins. Now, dogs, okay, this is just an example though. Cats are carnivorous, they're obligate carnivores, but dogs, this is a controversial thought, but a lot of people don't think. Well, okay, so I'm taught that they're omnivorous. That you could also call them facultative carnivores, which is basically the same as omnivorous. Omnivorous, but it's insinuating that they function better when they eat meat, but they can survive when they eat non-meat feeds like corn. But I don't know. I've got a lot of opinions about that. Okay, there's many types of digestion: mechanical digestion, chemical, fermentation. Fermentation is very important for herbivores and not very important at all in dogs and cats. I mean, it does a little bit in dogs and cats, but not much at all. Uh, in the mouth, the teeth vary between species. Herbivores have flatter teeth for grinding their cud, whereas carnivores have sharper teeth for tearing flesh. Salivary glands, for example, in cats, they don't secrete amylase in their saliva, and dogs secrete very little amylase. What does that mean? So amylase breaks down amylose. Amylose is a type of starch. Starch is a type of carbohydrate. As a matter of fact, if you were to break down starch, you'd have pure glucose. Or if you were to break down amylose, there's probably different types of starch. But it's just pure sugar, basically. Now, the tongue tastes stuff. It also stimulates appetite and starts those digestive juices, secretions. And then your nose, or the nose, olfaction, and literally chemicals enter your nose, and these chemicals are anything that has a smell. That smell itself is a chemical that enters your nose, and it triggers those receptors. And that's what causes you to smell things, causes these animals to smell things. Then there's the trigeminal system. This, I think it's also part of something to do with the olfactory system, but it detects creaminess or burning or cooling or pain. So like you can tell if something's creamy or if something's hot or if something's cold, or if something hurts by this system. And then your esophagus, it's part of the digestive tract again. It's a very muscular tube. You have to be able to swallow, and what that does is that moves. It's smooth muscle, so it's involuntary. But once you swallow, the food just goes down to your stomach. It also withstands abrasion, likely due to that those epithelial cells that I was talking about. And the function of the esophagus is that it moves food to the stomach via peristalsis. And then there's the esophageal sphincter that prevents food going back into the esophagus, but sometimes it does. That's called acid reflux. The stomach's job is to store food, to start digestion, and to actually, the stomach does the majority of protein digestion. That stomach acid, the whole point of it is to break down protein. It's got mucus on the stomach lining and the stomach lining, and it moves food to the small intestine. There's a whole lot of other stuff here. There's a liver, secretes bile, emulsifies fats, stores glucose and glycogen. Then there's the pancreas, aids digestion of pretty much all the energy supplying nutrients, carbs, proteins, fats, by secreting enzymes into the small intestine. It also, I didn't know this, it releases sodium bicarbonate into the small intestine to neutralize the acidity of the stomach contents. Didn't know that. And then it controls the level of glucose metabolism, or the amount of glucose in your blood, by producing insulin and glucagon. Yeah, too much glucose is toxic to the body. And if you get the glucose amounts out of whack, because glucose is required for certain organs, your brain, your red blood cells, however the body makes glucose. So it's not an essential nutrient like some people think. Carbohydrates are non-essential. Your body makes them. Anyway, small intestine, not as acidic as the stomach. Yeah, sucrase, maltase, isomaltase. This is I'll just review pretty much. Peptidases, bile, chyme, villi, microvilli. Yep. Dogs and cats have a tiny cecum, so that means they have very low fermentation capabilities because they don't have a rumen. Undigested food goes straight from the small intestine to the large intestine because it's not digested. Now that large intestine has some fermentation capabilities as well because it's right after the cecum, so the microbes kind of just pack in that area. Very limited capabilities, but still a little bit. And then the primary function of the large intestine is to reabsorb water and electrolytes. Acetate, propionate, acetate, propionate, butyrate. Those are the short chain fatty acids made by microbes. Okay, and that's pretty much it for nutrition. Now on to clinical. What was this class called again? I don't remember. Let's see. Critical thinking, clinical skills, and communication 1. Yes. Okay, so a lot of times when you're in a clinic, finding out what is wrong with the patient, again, the patient is the animal, the client is the owner of the animal. Finding out what is wrong with the patient is almost always something you can learn from the owner, just by learning what the history of the animal is, what the problems the owner's been experiencing with the animal are. You know, you got to ask open-ended questions, and then you got to know a thorough history of the animal, or else it's not really an exam because you don't know what happened, you know. Okay, there's many routes of administration. There's PO, which is per os, which means by mouth. There's IV, intravenous, which means in a vein. IM, intramuscular, in the muscle. IO, intraosseous, not done that often, that means in the bone. IP, intraperitoneal, which means into the abdominal cavity. PR, which means per rectum, so it's a rectal injection or a rectal administration. And then there's SC or SQ, subQ, subcutaneous, which means under the skin. And the subcutis. There's intervals. If you were to give instructions to an owner for medication, you can say SID, which means once a day, BID, twice a day, TID, 3 times a day, QID, 4 times a day, Q6H, which basically means once every 6 hours, Q3D, which means once every 3 days. And then there's metric stuff, kilo, decimeter, kilometer or kilometer, millimeter, micrometer. I'm just putting meter on the end. That's not actually here. Kilo, deci, milli, yeah, micro. Yep. Yeah, units. Yep. Liquid conversions. Ooh, yep. It's important to know because the rest of the world uses the metric system. America, we use gallons, quarts, pints, ounces, tablespoons, teaspoons. So okay, so oh man. First thing you want to do is determine the weight of an animal. Then so if you're giving a medication, determine the animal's weight, identify the dosage of the meds you want to give, calculate total dosage, and then you adjust the total drug dosage, considering keeping in mind the medication concentration, because it's not always the same. And it varies, you've got some animals are weighed in kilograms, need to convert it to pounds if you're measuring in pounds, or convert it to kilograms if you're measuring in kilograms. Sometimes the concentrations are different. Sometimes they'll give you a medicine that's 50% lidocaine, and then, that's probably pretty rare, but okay, 3% lidocaine versus 2% lidocaine. Very, very different. You got to do a lot of calculations, mental math, or with a calculator to figure out, these crucial differences, because a small amount could be enough to be bad news for an animal. Signalment plus history is important. I don't know what that means. PE. It's good to generate a problem list and rank based on the severity of the problem. Do your differentials. Good to have an ID system. Okay, there's diagnostics can refine those differentials, which is like CBC, chemistry, urinalysis, diagnostic imaging, etc. Then there's this mnemonic, which I'm not going to say aloud because it's not exactly a good word, but it's DAMNITV. It stands for degenerative, anomalous, metabolic or mechanical or mental or management, neoplastic or nutritional, idiopathic or inflammatory or infectious or immune mediated, traumatic or toxic, and vascular. those are the 7 whatchamacallits, 7 words. But it's good to know, like, diet. What's this animal eating? Appetite. Has this animal been eating more or less than usual? You know, things to ask to know, like, oh, is this animal doing okay or is it doing worse? Good to know. All right, and that's all. That's all for Tuesday the 19th. All right. Thanks for watching.